Hi, John Farr here from Polhemus, giving you a tutorial on the new FastSCAN 2. This is going to be a guide to all the different components and the actual setup and the operation. Inside the case, you have the wand, you have the system electronics unit, you have the interconnecting cable for the wand to the system electronics unit, and you have the sensor. Under the packing material, you have the power supply, the USB cable, the power cord, and the installation software. The scanner is easily connected and disconnected. It is connected to the SCU. The sensor is connected to the SCU. The USB cable connects directly into the system's electronics unit and then straight into your laptop or PC. Plug the cable into the power supply brick and then plug the power supply cable directly into the system's electronics unit. The sensor always needs to be placed close to the object that we are scanning. The electromagnetic source is actually located within the wand. The only word of caution in your setup is because the scanner is a hybrid, it uses laser technology and electromagnetic technology, you want to be careful that the environment is free of any large, highly conductive metals. As long as you don't set the sensor on a metallic desk or metal filing cabinet, for example, your scans should come out very, very well. So we go and we bring up our software. We then turn on our SCU. So once the unit is online and you pull the trigger on the wand, it will ask you to please point the wand at the reference receiver, pull and release the trigger. In scanning the object, the trigger on the wand is a two-step trigger. It's got a half pull, that sets the view, and it's got a full pull, which allows the laser to actually scan the object. The best distance is about 6 to 8 inches or about 12 to 16 centimeters, scanner to object. Once again, if I give it a half click, it changes my view. Half click, changes my view. So once we have the majority of the objects scanned, what we actually have is a point cloud, and you can page up or page down to zoom in or out. We have a polygonal mesh, and you can see the overlaps of the scan. So the scanner actually gives you more data than you need because it's easier to get rid of data than it is to add it. But the first thing we want to do is go to Edit and register our sweeps. This pulls the overlaps in just a little bit tighter. Next, if we go to our wireframe, once again we can see all the overlaps here. So what we want to do is break it down to a 1 millimeter resolution. And what that did, it took out most of the overlaps and it simplified the mesh, and it brought us from 12,000 points down to 10,000 points, 24,000 polygons down to 20,000 polygons. So it did reduce it a little bit. If we click on our surface simplification, what this does is it tightens the polygons where the resolution is required, and it loosens them where it is not required. And so your polygon mesh will look something like this, in which case the file is now 2200 points versus 12,000 points. But I am going to not use that. So now we go back to our solid surface, and we notice that we have some holes that need to be filled. At this point we go to our RBF, and you have four options: open a bounding box, close the bounding box, trim to data, or trim to edges. For this example, I'm going to trim to edges with a margin size of roughly 20 millimeters, and apply the surface. And as you can see, all the holes are nicely filled now. So we started with our basic sweeps. We then shrunk our file size, and we then filled the holes. However, if I wanted to send this to a 3D printer or to a carver, I cannot, because it does not have a watertight surface. So at this point I would go back to my RBF, and I would choose closed at bounding box, give it a 0 margin size, and apply my surface. And now what we have is a complete watertight surface. At this point, if I'm happy with my scan, I can export into over 13 different file formats.